All right, our last type of angle is dealing with an outside angle. And there's a couple ways outside angles can be drawn. You might see what we call two secants. Secants are lines that go through the circle. They contain chords that intersect, such as what you see below. You might see a tangent in a secant. Tangent's a line that just hits the circle at the edge, doesn't go through it. Or you might see two tangents. Whatever the case, they're actually going to follow the same rule. So if I want to know the measure of that angle, let me measure it and tell you what the protractor says. And it looks like it's about 31 or 32 degrees. I'll go ahead and say 31. And that's a little bit hard to figure out the relationship for you, but if you subtract these two values, 104 minus 42, you're going to get 62. Well, how does 31 relate to 62? It's half of it. So just cut that in half, and you're going to get 31 degrees. And that actually is going to apply to any angle that's on the outside. Where in the previous problem where we had an inside angle, we added them together and divide by 2. If it's on the outside, we subtract them and divide by 2. So what I call that formula is, if I inside the angle, there's going to be two intercepted arcs. There's going to be a big arc and a little arc. So I just say the angle formed outside is 1/2 big arc minus little arc. Or, as this is saying, half the difference of the intercepted arcs. So our goal is to get the big arc and little arc and plug it in and see what you get for your angles. So remember, it's the intercepted arcs, not the arcs that are outside the angle. So this 55 would represent a little arc. The big arc over here is unknown, but we're going to get that arc because we know all the arcs in a circle add to 360 degrees. So I know that around here, plus 55, plus 70, those all add, so we'll call this B, those all add to 360. So those two add to, let's see, that's 12, 125. And if I subtract the 125, I'm going to get 235. And let me double check that because my brain is maxed out. So there we go. We got our 235 for our big arc. We'll call that B. And our little arc, L, is 55. We'll plug it right into that formula. And 235 minus 55 is going to give us 180. And so X should be 90 degrees. A lot of times these aren't drawn to scale. When these pictures are drawn, people just kind of make up the numbers. So don't try to scratch your head and think, well, that's not looking like it's 90 degrees. It's not. But according to the numbers, they do work in the formula. Let's do a ratio problem. So we have arc ln, arc nk. So ln is a 1, that's a 1x. nk is a 3, we'll call that 3x. And kl is a 4x. And of course, these three arcs combine to 360, so we'll do 1x plus 3x plus 4x equals 360. And those combine to 8x. And 360 divided by 8, pretty sure that's 45. I've seen that a few times. 45, which makes all these arcs, this arc's going to be 45 degrees, this is going to be 3 times 45. That's 135. And this is going to be 4 times 45, which is going to be 180. Well, the arcs that I want to use to find the measure of the angle, because LMK is the angle outside, is the 135 and the 180. So I'm going to do half the 180 minus the 135. So what is half of 45 degrees? Well, that's going to be 22.5, I believe. So the measure of angle LMK equals 22.5 degrees. And if you want to double check that, divide by 2, and there's your answer. Boom. So we got 90 degrees, 22.5 degrees, one more on this page, and then we'll go to the next one, which has just got 2 more examples. There's a circular cabinet in the dining room. Looking in from another room at point A, you estimate that you can see an arc of the cabinet about 120 degrees. What is the measure of angle A formed by the tangents to the cabinet? All right, what do you get here? Well, let's see. I have 120 degrees. I only have 2 arcs. So this is the big arc, this is the little arc. That means the big arc is going to be 360 minus 120. And that's going to be 240. So to get that angle, 1/2, 240 minus 120. That's going to be half of 120, which is 60 degrees. We got a couple more. Y'all can try to figure these out, pause the video, see what you can get. 31, in the diagram of circle O, PQ is tangent to O. That, again, it just edges the circle here. Doesn't go in it. And PRT is a secant. Secant goes through the circle. If the measure of angle P is 56, and the measure of angle arc QT is 192, that's your big arc. What is the measure of arc QR? That's your little arc. So here's your angle, and let's write our formula. I'll call B for big arc and L for little arc. So angle equals 1/2 B minus L. So I'm going to plug in 56 for the angle, 192 for B. L, I don't know, so I'm going to leave that blank. Again, I'm going to times the 56 by 2. Now 2 times 56 is 112. So that's going to be 112. Let's take this up here, or down here. And if I want to figure out L, I can just subtract these two. It's not going to be negative, so just do 192 minus 112, and that'll be your answer. And L is going to be 80 degrees. So arc QR is 80 degrees. Now we did a problem like this on the previous page. It was number 29. So you might have want to try this one again, see if you can get it. Pause it. I'll work it out real quick. Pause it before I get it worked out if you want to try it on your own. So KA is 2, we'll put 2x. KC is 3, we'll put 3x. And CA is 5, we'll put 5x. Add them up. Solve for x. 180 divided by 10 is 18. To get the angle, plug in your value of x into the appropriate arcs. So that's your big arc, that's the larger of the intercepted arcs. And the 2x is your small arc, so that's your L. So 5 times 18 is, let's see, 5 times 20 is 100. 2 times 5, that should be 90. Is that right? Yeah, I guess so. 2 times 18 is 36. And so I'm going to do the measure of angle ABC is 1/2 90 minus 36. 1/2 of 90 minus 36. 90 minus 30 is 60. Minus 6 is 54. So that should be half of 54, which is 27 degrees. Whew, that's a lot. But I hope that helped. Please make sure that you go back and review all this before Wednesday. Thank you.